Bismillahirrahmanirrahim. Assalamu alaikum. Today I am teaching you what is scalability, speed up, and Amdahl's law. First of all, I will define what is scalability. Scalability is the property of a system to handle a growing amount of work by adding resources to a system. So, scalability simply means we can add more resources to a system, or we can remove resources from a system. A system is described as scalable if it will remain effective when there is significant increase in the number of resources and the number of users. Moving forward, what are scalability dimensions? Uh, so, uh, Scalability of the system can be measured along the following different dimensions. So, there are following basic dimensions that are physical scalability and load scalability, or scalability. So physical scalability, as the name suggests, physically. A system can be scalable with respect to the size, meaning that we can easily add and remove more users and resources to a system. Looking on the name users, the word users is related to a load, and the resources, the word resources is related to the word scalability. So so it means that physical scalability and the load scalability are related to the users and the resources of a system. The next is administrative scalability, the ability for an increased number of organizations or users to access a system. So if we are living anywhere in the world and we are running any organization, so we should access it from any part of the world. So this is basically administrative scalability. So now moving towards functional scalability, the ability to enhance the system by adding new functionality without disrupting existing activities. And so in functional scalability, we are just adding function, we are giving new functionality to, let's say, to our app. We are updating our apps. So actually we are adding new functionality in our apps. Now, what is geographic scalability? The ability to maintain effectiveness during expansion from local area to a larger region. Now I'm going to discuss scale out and what is scale out and scale up scalability. So basically it's called as a horizontal and vertical scalability. Scaling horizontally means adding more nodes or removing nodes from a system, such as adding new computers to a distributed software application. It will be clear after I will give you an example in the next slide. An example might involve scaling out to increase from one web servers to three. So for example, if we are currently running our application on a one server, so we can expand it to three server, so that whenever we faced any more traffic or any lagging in our application, we can switch to another server. So basically this is an example of horizontal scalability. So in this diagram, you can see in first example there is only one server, and in second diagram there are multiple server. So which one is better? So in which system we can say it's scalable? So obviously, in the second picture we can say it is a scalable. What does scaling vertically means? Means adding resources or removing resources from a single node, typically involving addition of CPUs, memory, or storage. Let's see. So in this picture, you can see there is the above picture is an example of scale up. So in within a CPU, we are adding more resources. Within one CPU, let's say uh, we are increasing RAM, we are increasing storage. So this is actually example of scale up. And so what is scale out? In the second one, you can see we are adding, let's say, more servers. We are increasing number of servers. So this is the example of scale out. So let's move toward Amdahl's law. What is Amdahl's law? Amdahl's law is a formula which gives the theoretical speed up in latency of the execution of a task at fixed workload that can be expected of a system whose resources are improved. So Amdahl's law is basically a simple formula. So this is a formula of Amdahl's law. In this formula, S latency is the theoretical speed up of the execution of the whole task, and S is the speed up of the part of the task that benefit from improved system resources. P is the proportion of execution time that the part benefiting from improved resources. So this formula can you can get more understanding of this formula by applying it. So if so in this example, actually I'm giving you the basic concept of Amdahl's law. So for example, if a program need 20 hours using a single processor core, we have a program that need 20 hours, and a particular part of the program which takes 1 hour to execute can 1 hour to execute cannot be parallelized. So in 20 hours, 1 hour is a part that we can't parallelize actually. So it's mean that 19 hours, which is 19 by 20 is equal to 0.95. It means 95% of the program we can parallelize, and 5% of the program we can't parallelize. So what does it mean? In next slide, you can see then regardless of how many processors are devoted to a parallelized execution of this program, the minimum execution time cannot be less than critically 1 hour. So it's mean that the whole 20-hour program depends upon the 1 hour program that can't be parallelized. So if we are able to parallelized our 19 hour program, but it will depend upon that 1 hour. So in a simple, if I will say that let's say uh, 19 hour program is executed in 15 minutes, let's say, but the other 1 hour part will take 1 hour to execute this because it can't be parallelized. In the previous example, 95% portion of the process is subject to speed up. P will be 0.95, which means 95%, and the portion will get benefit of speed up twice of original, then means S is equal to 2. So we will put it into the formula. The formula is S is equal to 1 divided by 1 minus P plus P divided by S. So by putting it, we can get the speed up of 1.907. So in last, this is simple graph. You can understand Amdahl's law by simply this graph. So in x-axis, you can see there are number of processors ranging from 1 to it's like 65,000 and so on. And in the y-axis, you can see there is a speed up. So if you can see there is a parallel region, the blue line say that your 50% of 50% portion of the program is parallelized, and in a red line there is 75, and there is another purple line 90%. So what actually this mean? Simply means that you can see the blue line. Blue line is the program have only 50% parallelized portion, means we can parallelize 50% of the program. So regardless of the processor, let's say you have 1000 processor, but the you can parallelize only 50%, so it's useless. So it's so we can't use our parallelized resources actually. And same in the green line, we have 95% of the portion which we can parallelize actually. So you can see the speed up lines, we can more speed up our program. And in blue line, regardless of the number of processors, we can't speed up our program because it has only 50% of the portion which we actually can parallelize. So and that's all for today. Thank you. I hope you got the basic idea of Amdahl's law and scalability.